Yeah, I got the email. So let's go over that. Okay. 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 Is this the book you're using? Okay, good. All right. Okay. Are your parents from Iran or Armenia? Oh, okay. My parents are from Bangladesh. Well, I'm from too. I've been here like 25 years, so. Okay. Yeah, I have a lot of friends from Hyderabad. Deccan, right? Deccan area. That's what they call. Okay, chapter 7. Oh, you want to go end of the chapter stuff? Right, right. I have those. Um, okay, okay, okay. Um, all right. So you want to start with number 2, right? 7.1, number 2. Did you get a chance to speak to Ben? Okay. Yeah, he's using the same book, so you probably could study together, you know. Okay. Number 1. All right. Okay. Normally distributed with sigma known. Okay. The first thing you need to know is that if you know the sigma, okay, you use z. Okay. And if you don't know, then you either use t, or you have to make decisions on some other things, like how big the size is, and all that. Like if the size is big enough, you just go with z anyway. But in this case, the decision was easy. Okay, you use z normal distribution. Okay, z table. What's the confidence interval for the interval x bar? What calculator do you use? Oh, okay. Okay, sigma over square root of n. So you'll have to look into the table and see what's 2.81. Okay. So look back on the z table. What page is it on? Okay. Okay. Standard normal. Okay, there you go. So you can use this one to find out. It's 2.81. So look up here. The next page probably. 2.81. So it's 2.8. The first one must be 0. Yeah, so it'd be 1. So you look at 2.81. You look straight down, and that's 0.9975. Okay. So if you draw this like this, the z point for this is right about here, 2.81, and the percentile for this one is 0.9975. Okay. So what this tells you is that this negative side, you can look up to. You don't really have to make that here. Do that here. You can look at negative 2.81, It's 0.0025. For this point, negative 2.81, 0.0025. Okay, so you're looking at a confidence interval that are between those two, right? Okay, so you don't want this 0.0025, and you don't want this one. Above this will be another 0.0025, right? You want the middle part, right? I tell my students to have 3 rows under this curve, one for x, one for z, and one for percent, so they don't mix up things. Okay, so you don't know anything about x and all that, so you just have to understand this and just subtract it, and that's it. That's all you need. So you subtract this one from this one, you end up getting 0.995. Okay, so that should be your answer for that question, right? So let's go back up. This is page 715. Let me write that down so I can come back quickly here. What was the last page we looked at? Okay, oh, there you go. Got it. Okay, there you go. Actually, we started doing 1. We need to do 2, right? Okay, but it's the same thing, though. You know, you get the point, right? Okay. Okay, jump to 2. Page 715, right? Page 715, and this is page 296. We can jump quickly. All right. Okay, let's work on 2. All right. So this is also sort of the same thing, written in a different way. So you need to draw the curve first, and you need to understand how this curve operates. Okay. The midpoint is always the mu. Okay. The mean, right? And the z for that midpoint will always be 0. Even before you get anything else, you know the midpoint will be 0. And the percentile for midpoint will always be 0.50, right? 50%, right? With half of those will be below it, right? So you know those things even before you read the question, okay? Now this question tells you that the confidence interval is 114.4 and 115.6. So basically, this one must be the one above must be 115.6, and the one below must be 114.4. Okay, so you're basically looking for the midpoint. You know, so how do you find the midpoint? You just average them. You know, so you add them up, 114.4 plus 115.6, and divide that by 2, and you should get 115. So this point must be 115. Okay, and that's it. Okay, for the second one, it's the same thing. 114 point. It'll be a little bit farther. It's going to be 114 on 1. A little bit further should be 115.9. Okay, okay, now the next part of the question is both intervals were calculated from the same sample data. The confidence level for one of these intervals is 90%, and the one is 99%. Which one do you think is 90 and which one is 95 and 99? Exactly. Pretty common sense, right? It's wider, right? So there's basically 2 extra percent here, you know, and 2 extra percent here, right? In the middle there's 95, right? And that's it, right? But you have to understand these things intuitively. Don't try to memorize too many formulas here, you know. See what, you know, see the picture, visualize it, you know, and internalize it. It's rather than, huh? Okay, for in this question right here, you needed this, you needed to look up the table and do it. So really, you don't need to use any formula for this. Okay, you're going to need this formula later on. Okay, x minus mu sigma. Okay, and all those things. But in this case, they did not even give you any of that. You just need to get the average, right? X1 plus x2 divided by 2. That's it, right? Common average. So you don't really you haven't even started like using the normal distribution formula yet. You're still just averaging it, So far we don't even need to use formula for this question. Okay? We're going to need soon. For this one, number 4, we will need the formula. Okay? So again, you're going to have to let me just draw it first. So you already know the mean, the z for midpoint is 0, and this is 0.50. You also know sigma is 3, right? These are things you know. Okay, let me just make sure this audio is working. 1 second. Okay, because recording audio is different. I just have to make sure. Okay, so X bar. These stuffs are not really necessary, I guess. So you start with this. The mean is 58.3. So put that in the middle. Okay. And then, n equals to 25. In this case, they did not give you the mean, right? They gave you this one. They gave you, so you could have mu x bar. Either one can be written here because you're trying to find the mu. Okay. So if you know the mu, okay, you can find the x using this. Okay. In this case, you know the x bar, so you're going to have to find the mu is going to be within this. You using your sample, you're going to predict what the real thing is. Real averages, and that you're going to find using this. And now n is this, and in the first question, you're looking for 95% confidence intervals. So you basically want that 2.5% here and 2.5% here, right? So this point, the percentile must be 0.025, and the percentile must be 0.975. Okay. So the z value for this, if you look up the table, it's going to be 1.96, negative 1.96. Okay, straight from the table. Okay. Now, now you need to find out what this value is and this value is. That would be your answer. Okay. And how do you find that thing? Let's call this mu. This value z1. Z1 equals to x bar minus mu divided by sigma over square root of n. So that is the formula. Okay. Okay. You know everything here except the mu. Okay. This is the only thing that's missing. Right. So all you have to do is plug in now and do the algebra. Okay. Negative 1.96 equals to x bar is what? X bar minus mu is 50. I'm sorry. X bar is given. So mu is the one missing. 58.3 minus mu divided by 3 divided by square root of 25. So when you put it in the calculator, and so you know how to do the algebra here, right? Okay, so that's it. Okay, so that will give you the value here, And for this one, you do the same thing, but this time you'll do plus 1.96 equals to 58.3 minus mu divided by 3 over square root of 25. Okay? All right. B, you do the same thing except you'd use 100 instead of 25. Okay? Everything else is the same. Okay? B, change n to 100. Okay, that's it. Everything else is the same. So C, you change this value. See this 1.96 negative 1.96 negative 1.96. So you change plus minus 1.96 to plus minus 2.558. Okay, 575 or 58. 58 is fine. Okay. Yeah, for this one, yes. Yeah, look up from the Z table. From Z table, yeah. Okay, number D would be compute 82% confidence interval with n equals to 100. So that I don't have memorized, so I'll have to look. What's the page number again? 715. 715. Okay, so it's 82%. So you have to look up here and see where is 82%. Right here. Between this and this, so 0.915, 0.92, I'll say, okay? 0.92, okay? So it should, yes. No, they gave you 82%. One second, let me just draw this first, actually. Let me show it to you here. Actually, I think this is not about percentile. This is about percentile, but we're looking at confidence interval. Okay. No, we don't know the Z. We have to find the Z. You're thinking kind of the other way. We know the percentile. We don't know the Z. So we have X, Z, and percentile. The percentile we're looking at here is basically this is 9% and this is 9%, okay? So our percentile should be 0.09 here, and the percentile should be 0.91 here, right? Okay, so we don't mix things up here, okay? So you have the percentile here. Now you look up the Z, and you actually have to look at 91 percentile here. 91 is right here, okay? So it should be 1.34. So this Z value should be 1.34. And this Z value, if you look up back there, 9%, it's going to be negative 1.34. Okay, negative 1 point right here. See 9% right here? So you're going backward now. Remember, when you go backward, you look in the middle of the table and find Z. So that's where this chart really helps you keep things kind of organized. This is 0, this is 50, so you don't mix these up. All right. So in this question, basically you change Z to plus minus 1.34, and that's it. The rest of the math is exactly the same. Okay. So page 296, go back there. Okay. All right. We have to go down. Yeah, that's right. Okay, 4. Now E. How large must n be if the width of the 99% interval for mu is to be 1? Okay, so we got to draw this one out. Okay, and you're looking for 99% confidence interval. So 99% in the middle. So you basically want 0.5% right here. and 0.5% right here, right? That's your goal. Now, keep your things neat and organized, Z and percent. The midpoint is 0 and 50% here. Okay, what is given? What's given? Sigma is 3, didn't change. And what's the mean? The mean is 58.3. So you put 58.3 here, right? Now this is telling you this interval, the width of this. So this must be 0.5 higher this way and 0.5 lower this way. Yeah, it did not. I think it, even if it was something else, it would not make any difference as long as sigma is 3, you know, because it would still be plus minus 0.5. So it'd be 58.8, but that's a good question. 58.8 and this one is 57.8. Okay, so you got those 2 points, right? Plus 0.5 minus 0.5. So you know the difference is going to be 1. The width is going to be 1, right? Now you got to find the Z for those 2 points. Okay, how do you find the Z? The Z would be 99 percentile, well, 995. So you have to look up the chart. So the percentile must be 0.995 here, and percentile must be 0.005 here, right? Because 99% will be in the middle, right? So you can look up the chart, and you have to go backward now again, and it will give you 2.58 for this one, and negative 2.58. I probably should show it to you because you have a little bit confusion here. 715. Okay. See, you're looking at 0.005%, so you have to look here. Where'd it go? 2.58 right here. Okay, so it's right in the middle of these two, right? So you look it up here to find negative 2.58 and look on the other chart for 0.995. Okay, and that helps you find this other one. Okay. All right. So Z is that. So you know Z is going to be equal to X bar minus X minus, in this case you can just say X minus X bar because you already have X, and then you have sigma divided by square root of n. So the only thing you're missing here is this. You know, you got everything else. And actually on top you have the width. You know, this is just the width. Together, I'm going to send you the notes. You don't have to write this, okay? I'm going to send all these things I'm writing and the video too. Right? All right. So what do you know for the first one? You know 2.58 equals to 0.5. Oh well, actually width over 2. You know, it should be width over 2. 0.5 divided by sigma is 3 divided by square root of n. So now you can just move things around a little bit and find what n is. Let me just finish it up. So 2.58 times 3 over square root of n equals to 0.5. So I'm going to take square root of n to the other side. So you'll have 0. Bring it to this side. So you'll have 2.58 times 3 over 0.5. Okay. All right. So you square this. So 2.58 times 3, 0.5 square. Okay. And the important thing to see here is, even if it's like, let's say 38.01, okay, your n is going to be 39. Okay. Remember that it has to be above it. It's not like you don't round it. Okay. So actually, in that case, I would really say you should pick 3 here. In this case, 2.58. 2.58. So it's between 5.8 and 5.75. See that? So maybe you should just, instead of 2.58, you should pick 2.575 to be more accurate, you know. So that'll probably be a better way to do it. Okay, 2.575. 0.575. So plug that in. So you'll be more accurate in case it goes over. 5.7575. That's it. All right. So what does your calculator say? What is n? $238.70, right? So your value is 239. Okay, that's it. Okay, you're going to do the same thing for. Okay, is there any other part of this question? I don't remember. Okay, that's it. Okay. Okay, so that's it. All right. Okay, now next question is what page is that? Some point. Okay. What's the page number? $283, which means 7 more pages, 3 or 4 in here. Okay. Okay, question number here, 12, 14, and 20. Okay. Okay, what did you do in this chapter? You started T. Oh, you started. This is proportion. Okay. Oh, not proportion. Oh, it's the same thing. Using S. That's it. Okay. Population proportion. You sure you're not allowed to use TI-83? The other guy does use TI-83. Different teacher, I guess. But he doesn't let you use TI-83? Because, you know, in statistics course, from here on, even going back to binomial and stuff, you're far better off having a TI-83 or 84 calculator. There's so many things, you know, you can do in it. It'll make your test much easier. If nothing else, you can always check, you know. I want you to understand this because this is the right brain exercise, but you still need to do well on the test, right? Okay. Okay, so that's, so let's do number 12. A random sample of 110 lightning flashes in certain region because n equals to 110. Okay. So the mean was 81. Not mean actually, X bar, right? X bar is 81. X bar is 81. And S is 0.34. Okay. 99% two-sided confidence interval, so you will have to draw it. And in the proportion one, there's a bigger chance of mixing up Z and percentile because even the number is in proportion, you know, even the X bar is in point, you know. So you have your X, Z, and percent. So this one is 0.81, okay. This one is 0, and this one is 0.50, okay, the middle. Okay, see how easy it is to mix this up with the percentile or Z. So if you keep it separate like this, you'll have it organized. Okay, and then 99 percentile means you're looking at half here, okay, and half on the top, right? Half on the top and 99% in the middle. So this must be 0.995. This must be 0.005. So our Z was 2.575 we saw in the last question, and the z must be here 2.575 negative. Okay, so you got these two. Now, what else you need to know? You need to find this. So this is pretty much the same thing we did before. What are we missing here? This proportion actually this is x bar. Okay, the x bar minus mu should be s over square root of n, which makes it. Are we using t here? You're not using t here. This is large enough. That's why. Okay. What's the difference between what is it? X sigma. Sigma is population. Okay. Like for example, you know the population standard deviation already. Okay. Sometimes you will know it. Yeah, but in most cases, in practical life, you usually don't know. Okay. So yeah, this is like the first step going toward T. Okay, so I mean, you will rarely use Z table in real life. Well, when it gets big enough, you do, but well, anyway, we are slowly going toward harder stuff. So you need to go through this process of more uncommon stuff that are easier to comprehend. Okay, so so in this question, we know the middle is 0.81 minus mu, which we don't know. Okay, and then this one is going to be f, which is 0.34 divided by square root of 110, and the z will be in the first one. Let's say it's going to be 2.575. It's going to be 2.575. Okay. So you plug that in and do the algebra and find those 2 points. Okay, that's it. That's all there is to it. All right. All right. Yeah, that's it. Okay. And you interpret it. You expect that the mean to be between 99% of the time. The mean will be between these two. That's how you interpret it. All right. Next question is number. Let me look at the email. Number 14. Do you have a TI-8384 calculator? Yeah, I think it's worth it. it's even worth the drive. All right. Is there much difference between this question and the last question? Not really. The only difference is 95%. So instead of 2.575, it's going to be yeah. It's similar to this other one we did, not this one right here. The N question we did is very similar. Okay. Okay. Number 20. All right. Oh, tomorrow we're going to go an hour, right? You said wanted to go an hour tomorrow. How is 12:30? Sure, sure. Also, we started at like 11:05. Can we go like 50 minutes today, an hour, 10 minutes tomorrow? Is that okay? Okay. So what time tomorrow though? 12:30 is good? Okay, let's do 12:30 tomorrow. All right. Okay. So we can stop at 11:55. All right. So where is this question number 20, right? Okay. Reported that in a survey of 4722 American youngsters, so n equals to 4722. When this data is large like this, we can just, even though if you don't have the sample standard deviation, you can use, I mean, you can use Z still. It's so large that you feel pretty confident. And the reason is, I want to explain to you the reason though. Okay, let's say you have a sample. Let's say you don't know how the data is spread out. Okay, you're going to use a sample to predict it. You have to be very careful, right? You cannot really be very conservative. I mean, you have to be very conservative. You cannot really just follow the regular Z table way, right? You don't want to lose your job by predicting, like, too close to the mean when you should not. You're not confident enough, right? So when you use sample standard deviation, you end up using the T table, which is actually something we'll do next. So in using T table, you're just being very conservative, okay? But if you know the population standard deviation, you pretty much know how the data is spread out. That's when you end up using Z, okay? Well, I'll show you when we go over the T table. I'll show you, okay, how it works. Okay, let's just stop here because it's like a little bit going too far ahead. Okay, because we'll have to do that next after in a short time anyway. Okay, so but I just wanted to show you why this is important. Okay, the more data you have, the more confident you are, right, about your prediction, right? So just goes like that. Okay, so n is okay. 15% is seriously overweight. So this is X bar is 0.15. And you're looking at 99%. So you know this midpoint is going to be 0.15. And again, see, if you keep it like this, then you won't mix this 1.15. You won't think this is percentile. You won't think this is Z. Those will be all wrong. So you have to keep it easy. This is always 0. This is always 0.50. Okay. And then you're looking at 99 percentile. Again, you're looking at 0.5% here and 0.5% here, which you don't want. You want the middle 99%. So your percentile here is going to be 0.995. The percentile here is 0.005. Okay. And then here you have 2.575, and you have negative 2.575. Okay. And then from there, what you do is, where did it go? You find the Z, I guess. I mean, not Z, the X, I guess. Okay. Okay. So since n is really huge, you can just, but the standard deviation becomes really, I mean, the width becomes really small. I think that's what they wanted you to. What am I doing? The X bar is 0.15 plus minus. Have you seen this one where you? Okay, let me just write this formula down first. X bar X mu equals to X bar plus minus Z, okay, square root of n. Okay, so that would be 0.15 plus minus. This is essentially the same formula as this. They just move things around. So you don't really have to memorize this. You can use the other one to find this as well. Okay. And I in the beginning I kind of want students to just learn that one formula because you're already good at algebra. So just put it in, and instead of you're already being bombarded with information, right? So I don't want to make you memorize too many formulas here. So Z is going to be 2.575 times S is what is this? Oh, 15%. We got to calculate the S here. We don't know S yet. Wait, the S has to be first you have to calculate the S square. Okay, S square will be PQ. Okay, and S is going to be square root of PQ, which is square root of 0.15 times 0.85. So whatever that value is, what is that? Can you use the calculator to it? Okay. It's going to be 0.357. Are you sure? That's huge. Oh no, that's okay. That's okay. Yeah. Wait a second. That looks really big. 0.357. Yeah, that works. So divide that by square root of n, which is 4722, and that is the range. Okay. That will give you what you need. Okay. I guess that's it, right? So next question is 7.3, next chapter. Have you seen this formula though? When when you're going with percentages, you can use this formula to find out what the sample standard deviation is. Okay. Okay. Here, look at this T distribution. Now we are starting T. Okay. How T works is see, this is your normal distribution, but if you don't have enough data, okay, you have to be conservative, and you have to use a table that's more spread out. Okay, and the more data you have, the more you're going to be closer to the Z. Okay, and eventually you have enough data that it's going to be so close to the Z that it won't even matter. It'll be exactly like the Z. Okay, so right. When it's large enough, then what's the point of being conservative? We have enough data. Okay. So again, look at this. This looks familiar, right? Exactly the same thing. The thing with T is degrees of freedom. That's the new thing. Okay. And degrees of freedom is something that you're going to use for T distribution, for chi-square distribution, for ANOVA, regression, many different things. So this is like the beginning of that. In Z, you didn't have to worry about that. The degrees of freedom is always n minus 1. Okay. So if let's say your sample is 10. Okay, your degrees of freedom will be 9, and you're going to look up a table that has a degrees of freedom of 9. Like for example, let's see. Let me show you the table. Here you go. So this is essentially the Z table written in a different way. For in the Z table, you are always given Z's and the percentages in the middle. Over here, it tells you, okay, this is my this is like the 5%, the 5 top percent, or this is like 2.5% of the top. What is the value for that? Look, when we only had one sample, the Z value was the T value is 12,706. Okay, when you have like let's say 10 samples, I mean not one sample, I should say 2 samples because degrees of freedom is 1 less. So when you have 10 samples, you have to look at 9, and the value is 2.262. When you have like let's say 121 samples, we look at 1.98. And look, when you have 1 million samples, see it comes down to just like Z. Remember 1.96, right? Z had 1.96. Remember 2.575 we saw for infinity? That's for 99%. So, that's the table. So this, yes, yes. Okay. In this case, a lot of times you can have like 10 samples, but if you know the population standard deviation, that's the first thing I drew in this book. On the first page, see this? If you know the population standard deviation, it doesn't matter. You don't need to worry about T. You can use Z. Okay. Okay. Now you just have to learn to read this table in a different way. It doesn't give you every value like Z table does. It only gives you the critical points. You know, the 95 percentile, the 99 percentile. This is 99 percentile point. You know, you have to look at the picture and see what this is saying, and use the table, you know, accordingly. All right. So, okay, it's not that much harder. It's just a little bit different. Okay. All right, let's go back to page about 300 something, 310 maybe. Okay, let's go back up. Yeah, that's the chapter. Okay. Okay. See, this is the picture I was drawing there. See, the Z was the highest, right? And the more T you have, like this, the smallest one was T5, then the bigger one is T25, the biggest one is Z, right? Very important to understand this. Again, this shaded stuff that they do here, this is exactly like Z, nothing new. Okay, it's all symmetric, and you should also use my copyrighted table that I put here with 3 things. Okay, not copyrighted, but I should copyright it. Only my students know it, so you can kind of keep things separately. Okay. Okay, one sample T confidence interval. Okay, when you're just worried about one thing, you're not 2 different things. Well, so I'm not even going to go there. So you're just going to get the mean of one thing, and you just get a bunch of samples. Okay, add them up, get the average. Okay. And then you get your X bar from the average, get your sample, calculate your sample standard deviation in those tedious way. Remember how you subtract and then square it, and you know, add them up, divided by n-1 and all that. Anyway, I don't think you have to do that here for this test, for this chapter. They'll probably give you those anyway. And then you essentially use Z distribution to do this, you know. All right, prediction interval for a single future value. So this is something we basically pick up from, you know, that last things we know. So nothing new here, you know, just using this small sample and do the same thing. right? So you should be able to reproduce this. Okay. Oh, things will get kind of fishy right here. Okay, you have to do this already. Okay. Non-normal population distribution. Okay. All right, they made a little bit jump here. So I would say, I mean, what we have done so far, I think you should study this again and practice this. And tomorrow when we start again, we should work on this and, because I don't want to make a big jump here. If you study those, what we'll do in the future from here on will become much easier. All right. So I'm going to save this. Stop the recording.